So we'll start with the networking in Microsoft Azure. Now, the question is what networking has to do with Entra ID? See, what you want to understand here is uh, look for the long-term perspective. You should not think in the near-term perspective that I am going to work in a project wherein they are dealing with Entra ID and I will be working on Entra ID capabilities. You need to understand at the end of the day the actual implementation of a technology. So when I say Entra ID is a service that falls under identity and access management domain of cybersecurity. Cybersecurity has 9 domains. Out of those 9 domains, one of the domain is identity and access management. Under identity and access management domain, we primarily deal with identities, provisioning and management of identities, and their access to various systems and resources in the environment or in the network. That's what identity and access management domain is all about. In this domain, you basically provision identities, you manage the life cycle of those identities, which basically relates to joiners, movers, and leavers that we will do in detail when we start with Entra ID. Right now, I'm just trying to set the context here that why are we doing these core services? What's the significance of it? So when it comes to Entra ID, at the end of the day, what are you going to use Entra ID for? You are going to use Entra ID for authentication of identities for applications, workloads. These applications and workloads could be in Microsoft Azure. They could be outside of Microsoft Azure. They could be third-party applications as well, which are outside of Microsoft Azure that you probably integrate with your Entra tenant so that Entra ID as a service can authenticate and authorize your identities to those applications. So we use Entra for authentication of identities for applications and workloads, right? Now, these applications and workloads could be in cloud, outside of cloud. They could be configured in hybrid mode also, which basically means that networking plays a crucial role here because at the end of the day, after authentication, the access needs to be granted. So let's say you configure an identity to authenticate. However, that identity is not able to access the application because there is something to do with networking. For that, you pass on that ticket or that request to your networking team. That is where the challenge lies. You should be able to visualize what is not working right here and what could be done to fix it. And that knowledge comes when you understand the dependencies or surrounding services that my service interacts with. And networking is that service that Entra will interact with. Now, you will say that I don't want to learn networking. I'm quite good with Entra only. I will continue to work with Entra. I will only have one question. Will you work with TCS throughout your life? Will you retire from TCS? If the answer is yes, go ahead and work with Entra only. But if the answer is no, or if the answer is maybe, or if you are not confidently answering this question, then don't just depend on Entra ID. This is just one technology. It will not take you anywhere in future. You today, as we speak today, looking at the challenging times that you have in the employment, market, you need to have skills. You need to have knowledge of multiple technologies or the technology that you have or that you are SME of. You need to have good knowledge of the surrounding technologies that it interacts and coordinates with. Then only you become an SME. Otherwise, you know, you will find yourself taking help from other SMEs or other colleagues all the time for anything and everything. So if you really want to be a good consultant or an architect in the long run, merely having Entra ID knowledge will not suffice the purpose. You should have good knowledge of core services of Microsoft Azure. This is something that your management recognized, and that's where they said that we don't want to do SC300. We want to do SC300 with core services of Microsoft Azure because that's what we are going to deal with in the long run. So let's understand the networking part here. So when it comes to networking in Microsoft Azure, you know that Azure is a public cloud. Now, definitely, since we are covering the core services, I will not get into the depth of core services because we are not doing AZ10 core certification here. If you want to get into the depth of these core services, I would probably suggest you to go through AZ 104 Learning, which is available on Microsoft Learning, which is also available on my channel, wherein I have a recorded session for AZ 104. Or you can go through courses which are available on edtech websites like Coursera, Udemy, and you can come back with questions if you have any. Here, our focus will be on introducing the core service and doing some hands-on lab around that core service so that you will have a fair idea about it. So we will start with the networking. Now, why do we build a network in public cloud? That's the question. So Azure is a public cloud, and since it's a public cloud, it is used by everyone, which basically means that there is a high probability that in the same data center, on the same hardware, I have my competition, my competitor, hosting their applications and workloads also. So how do I ensure segregation? How do I ensure segregation of resources, that my resources are segregated or separated from other businesses or from my competitors? That's one thing. That's the question that comes to my mind. How do I ensure segregation of resources? The second use case that comes to my mind is, how do I control network traffic to my applications, to my workloads and applications hosted in Azure public cloud? That's the second thing. So how do I control that traffic? I'm saying, how do I, because in on-premises, you have complete control. You can always define what kind of incoming and outbound traffic you want to allow, ingress and egress traffic. Now, in public cloud, there are some terminologies that changes. For example, in on-premises, we say incoming and outgoing traffic. In Azure, we call it ingress and egress. It's equivalent to incoming and outgoing. So ingress is incoming and egress is outgoing. Now remember the thumb rule for cloud. Thumb rule is, what comes in is free. What goes out is paid. That's the thumb rule of cloud. Okay, let me explain that. So this basically means that if you upload something into the cloud, there is no charge that cloud will take. So if you, let's say, if you upload 1 terabyte of data in Microsoft Azure storage account, Microsoft will not charge you for bandwidth, will not charge you for that network traffic. It will definitely charge you storage space for 1 terabyte at the end of the month, whichever the storage repository is, whether you are putting that data into a managed disk, whether you're putting that data into Data Factory, Databricks, whether you're putting that data into a storage account container, whether you are putting that data into an Azure SQL PaaS database, depending on the storage repository, Azure will charge you for the storage. But for the movement of data, Azure will not charge you. So you can bring any amount of data into cloud. You can bring anything inside cloud and there is no charge for it. However, the moment you try to download anything or transfer any data from source to destination, now destination has to be outside of cloud. If you are transferring, let's say you have two virtual machines in Azure, right? And one virtual machine is in East US, the other virtual machine is in West US, and you're transferring some data from East to West. There is no charge for it. Why? Because it's within the Azure network backbone. However, if this virtual machine is Azure VM and this virtual machine is AWS EC2 instance or an on-premise server or VM, then definitely there will be a charge. Why? Because now the destination is outside of Azure. So Azure will charge you for egress traffic. Outbound traffic is always charged in Azure. Inbound traffic is not charged in Azure. So you can bring in any amount of data in Microsoft Cloud, in any cloud, without paying even a single penny for that bandwidth. However, when you take data out, they will charge you for it. And there is a reason behind it. The reason is cloud service providers do not want to lose a customer. See, when you are putting data outside of cloud, it may probably mean that you are kind of planning to terminate your relationship with them. You are moving all your data outside of Azure to on-premises or to other cloud. So you are probably planning to close the relationship. And at that point in time, cloud will charge you. If you are doing any application transaction within cloud, the traffic remains in Azure network backbone, then there is no charge. If it is outside of cloud, there is a charge. The other thing that you will realize, I would say, at some point in time, I have seen a couple of customers moving out of cloud. They migrated to cloud thinking that cloud is a great place to be at. It will give me a lot of cost benefits. It will provide for availability, fault tolerance, disaster recovery, and whatnot. But in the interim, they realized that cloud is not a place to be at because they ended up paying more than they expected, or they did not get the performance that they expected to get in cloud. So they decided to move out of cloud. And that is where Azure charged them for egress traffic. In fact, when you are moving more than a specific amount of data from cloud, moving out of cloud, they will put throttling. Throttling is another concept. Throttling basically means restricting movement of data beyond a certain limit. So they put a throttling. They will throttle your account, which basically means you will not be able to move more than, let's say, 1 GB of data outside of cloud, 100 GB of data, 1 terabyte of data, depending on how much data you are moving, who you are, how much business you are giving to Microsoft. So that will be decided. That's known as throttling. So these are some of the concepts that you need to be aware of. So first thing, thumb rule of cloud, and this is common for all the clouds. What comes in free, what goes out, there's a charge. Incoming is egress and outgoing. Incoming is ingress and outgoing is egress. Is everyone with me on this?
Yes.
Okay. Next is, why do we need a network in Azure cloud? So we want to build a network, or we need a network in Azure cloud because we have these objectives. The objectives are that I want to segregate my resources, segregation of resources from other customers, or I would say competition. Second, I want to control network traffic to my workload and application. I want to decide what traffic I would allow, what traffic I would not allow, right? So that's the another thing that I want to do. So I want to segregate resources. I want to control network traffic, and also I want to apply security controls for movement of data from source to destination. That's the another use case that I have in mind. So I want a separate network, a private network in cloud that is only accessible to my identities, to my employees, to my resources. So to get a private network similar to LAN in the on-premise. LAN is local area network. So we have local area network in on-premise. We want to create a LAN that is only accessible to my business, to my domain. That is why I actually need a network in cloud. That is the reason I need a network in the cloud. Are you with me on this? Is everyone with me on this?
Yeah.
Yes.
Okay.
Yes.
In this network, the network that I will build, I will host my resources in the network so that no other customers or my competition will have access to my resources accidentally or intentionally. That is why I need a network in the cloud. Now let's understand the same from the presentation. So the service that we use in Azure is known as virtual network. Virtual network is the service name. The same service in AWS is known as virtual private cloud. So it's my private cloud or private network. This is how a network looks like. So we create a network. That network is further segmented or divided into multiple subnet. Subnet stands for subnetworks. Why do we create subnets? So that we can segregate resources based on their role and characteristics. So I have multiple applications. For example, my Active Directory domain service, DNS, DHCP servers. I have my production application. My application is a three-tier application. It has a front end, back end, and middle tier. I want to separate them so that I can put appropriate security controls. That is why I create subnet. So I create a virtual network which is similar to a LAN. Then I create subnetwork which is similar to a VLAN, virtual LAN. And inside subnet, I provision resources. Those resources could be a virtual machine, it could be a load balancer, it could be other Azure services like app services and other services. And my network also allows me to communicate with other networks. Other networks like in on-premises, if I have multiple on-premises sites, if my on-premises sites also have networks, which is LAN and VLAN. So if I want my virtual machine here, let's say this is one virtual machine, and in my on-premises office, I also have a virtual machine. And just imagine that it's a two-tier application for which this is my front end and this is my back end. I'm putting my backend tier, which is my database in on-premises, and the front end, which is my web layer, is configured in Azure Cloud. So I want my front end to communicate with backend, and for that, the network in which these two servers resides, they should be able to communicate and talk to one another. So for that communication, I would need to create a VPN tunnel or an express route connectivity, which is a dedicated VPN. So network also allows me to create a virtual private network or VPN tunnel. So that's the another capability. And my virtual network will also communicate with additional virtual networks which are in Azure in the same subscription, across accounts as well. So for example, Anusha can have her virtual network communicate with Monisha's virtual network. And that way, Anusha's virtual machines can communicate with Monisha's virtual machine. That is also possible. And in this case, Anusha and Monisha, they have two different tenants. They have no connection in between. I would say Anusha has a separate subscription, Monisha has a separate subscription, and their tenants are also separate. They have absolutely no trust in between. So virtual network will allow resources to communicate even without creating a trust in between the domains or in between the directories. That's the another benefit that virtual network bring on the table. So let's understand the capabilities or use cases. The first capability is isolation and segmentation. So this provides isolation. Isolation, why? Because my resources in my virtual network are only accessible to me, to not other customers. For example, when you create virtual network and deploy a virtual machine in it, the other person cannot access it, your virtual machines, and you can't access the others' virtual machines. So isolation. It provides segmentations. Segmentation so that you can apply appropriate security controls. The example could be, let's say I provision, I have a three-tier application. This is my web tier. This is my app tier. And this is my DB tier, which is my backend. I have a three-tier application, web, app, and DB. And all of this is installed on these virtual machines. I'm using mouse to draw, so forgive me for my drawing here. Just try and understand the concept. If I put all of them in the same network without segmenting them, when the traffic comes from outside, this is a public facing application. When the traffic comes from outside, web tier is configured to accept traffic on port 80 and 443, right? 80 and 443 where web receives the traffic. App is configured to receive the traffic on, let's say, port 8080 or any other port that you have in mind based on your application configuration. and DB is SQL Server, and you know SQL accepts traffic on port 1433. That's the port for SQL. Now the challenge with putting all of these three in the same network without creating a segment is that when the traffic comes from outside, that traffic can also reach to other servers, right? And if there is any malware that comes from the internet, any spyware, malware, ransomware, it can easily spread from one server to another because they all can communicate with one another without any restriction because they are part of the same segment, right? So this is a drawback. This is a bad network design. And that is where what we do, we create segments. So now I will create 3 segments here. And in each segment, I will put my tiers, application tier. This is my web tier. Second segment is my app tier. Third segment is my DB tier. And all of these 3 segments are part of the same network. Right? Now, what will happen when the traffic comes? I can always have restrictions. Restrictions in the sense that since this is my web, this is my app, and this is my DB tier, I can put a restriction in the form of ACL, access control list, which is the concept of on-premises. In Azure, we use the concept of NSG, network security group. So what I will do, I will create a network security group that will put some restrictions. For example, I will not allow my web tier to communicate with DB. Why? Because web is customer facing, internet facing. Web is prone to security threats, and I don't want that threat or that malware to spread to database because database is my critical system. I have all my data here. So I don't want web to communicate with DB. And that is only possible when I create segmentation, when I segment these roles into their separate network so that I can put policies. I will create a rule that web will communicate with app, app will communicate with DB. So there is no direct communication between web and DB. I can also put rules in the sense that when app communicates with DB, it will only communicate with on port 143. So if app sends any traffic other than on port 1433, it will be denied. So this is the segmentation. This is the beauty of segmentation. Segmentation is helping me to create appropriate controls so that I can filter the traffic based on my application requirements and do not have an environment where everything is allowed to communicate with everything. That is not good for a security perspective. So that's the benefit of network. Now you will realize that network is a security service. In Azure, in cloud, network provides security. Security, which is isolation and segmentation. So that's the one use case of network. The next use case is communicate with the internet. If these virtual machines wants to communicate with the internet, which is outbound traffic, if web wants to communicate with the internet, outside internet, that capability will be provided by network. So network will provide net, which is network address translation. Net is the capability that will replace the private IP of this web server with virtual network public IP so that the traffic can reach to the internet. Because private IPs are not routable on the internet. You cannot browse the internet with private IPs. Now you will say that I can browse the internet on my personal laptop and I don't have a public IP. You actually have a public IP which is being provided by your ISP. So when you browse the internet, your private IP from the laptop, which is coming from the router or the device that is configured by ISP at your home, is replaced with the public IP of the ISP, and then the traffic goes to the internet. And when the response comes from the internet, then the same public IP is further replaced with your private IP, and you see the response on your web browser. So that's how internet works in a short span. I will share a video with you that is a 9 minutes video that will clarify all the doubts, bridge the gap. If you have any with respect to your understanding of how internet works, how it all communicates over the internet, you can watch that video in your spare time. I'll share the URL of that video. So that's the second thing, that it allows me to communicate with the internet. Third, it allows me to communicate between Azure resources. So my network also allows me to communicate between Azure resources. So when I want to communicate, when one machine wants to communicate with another, let's say when web wants to communicate with app, my network will allow that communication. So that's the another thing that network provides. It allows the communication and it also allows the restriction. It also have restriction capability. Next, communicate with on-premise resources. As I said, when this machine wants to communicate with this machine, your network will allow the communication by virtue of a tunnel that will be created. Next, now what are my on-premises communication capabilities? So if I want to communicate with on-premises, if an Azure virtual machine wants to communicate with on-premises virtual machine, there are three options: point-to-site virtual network, site-to-site virtual network, and Azure Express Route. Point-to-site basically means when a limited systems wants to communicate with limited systems. Two or three systems here wants to communicate with on-premises. Site-to-site basically means the entire virtual network and all the virtual machines in that network can communicate with the other network. So site to site basically means this virtual network will will have a tunnel, will have communication with the LAN of your office, the local area network that your office has. That's the site to site VPN. Now there's a drawback of this approach. The drawback is that the traffic is over the internet. In between there is internet. And since there is internet in between, there is a risk of interception. Your traffic may get intercepted. There is a risk of CIA, confidentiality, integrity, and availability. So to overcome that risk, Azure also provides you another option, which is Express Route. Express Route basically means it's a dedicated tunnel, which basically means from your network to on-premises, a dedicated tunnel will be created. I say from here to here, a dedicated tunnel will be created. And only you will be sending traffic in that tunnel. The internet will not come in between. That's the concept of Express Route. If you want to understand these connectivity options in detail, this is the slide that can help you. Here you can see hybrid connectivity options. To your left, you have on-premises site. To your right, you have Microsoft Azure. Now, in Microsoft Azure, you have a virtual network that contains some virtual machines or resources. You also have public services of Microsoft Azure, like Azure App Services, Azure PaaS Services, and you also have SaaS services of Azure, which is Microsoft 365, Skype, Link, and other services. So if you want connectivity from Azure to on-premises, these are the options. If some devices, which is a couple of laptops or desktops, wants to communicate with Azure virtual machines, you can create a point-to-site network. What is hidden in this image is internet. It is faded basically. This is internet. So you can see the traffic is over the internet. If the entire site wants to communicate, this entire office, instead of a couple of systems, the entire office wants to communicate with Azure, then you can create this tunnel. But this tunnel also is over the internet. You can see the path is over the internet. And then if you don't want to send traffic over the internet because there is a risk, then you can create a private WAN or private tunnel, which is known as express route. So you can see the traffic from your office goes to your private WAN. From there, it leads to express route, and from there, it reaches to Azure, all the three options in Azure, all the three services. So in this way, your traffic never goes to internet. And that's the secure connectivity option. But this is very expensive, very expensive. And most of the companies only use this tunnel for their mission critical traffic. When they want to send some secure data from on-premises to cloud or cloud to on-premises, for that traffic, they use this tunnel. And this tunnel has a failover link also. First of all, this tunnel never fails because you have 99.99% of SLA. Even if this tunnel fails, then you will have a failover link, which is VPN link, site-to-site VPN link. So if this tunnel fails, then the traffic will take the VPN link and will also reach to Azure in this case. So this is my connectivity options, which are available in Azure. And here is the video that I was talking about, how internet works. If you want to understand, I'll share this URL with you. Watch this in your spare time, and you will get the information that you need.
investments lead to the financial security.
I'm putting the link of video in the chat window. Watch it in your spare time, and you will definitely thank me for this video because this will clarify a lot of doubts that you may have in mind. Probably, somebody may ask you that, okay, you are a technical person, tell me how internet works. And you need to explain that in technology, then this is the video. If you want to explain that in a layman terminology, then it's a different thing. But this video actually tells you how it all happens when you send some traffic from your system to a server. And when the response comes from that server, what all devices are included, what all port and protocols are included, how the traffic leaves your system and reaches to the destination and comes back as a response. This video gives you that level of information. So watch this video in your spare time. Now, coming back to virtual network concept, as I said, your virtual network is giving you a lot of capabilities, which is the capability to communicate with the internet, communicate with on-premises systems, and then it also allows you to filter network. So we can do the network filtering. I'll open another presentation that will help you. The perfect example of network filtering is the presentation visible to all of you?
Yes, perfect.
Okay. So you can see here, it's a three-tier application. It's a three-tier web portal, cloudexpert.com. And what is happening here, you can see the web tier. The web server is in web subnet. Then we have created an app subnet wherein the app server is hosted. Then there is a separate database subnet where the database server is hosted. And all these three servers can talk to each other by design. However, we have created some network security group rules or some filtering wherein I'm not allowing any traffic from web to database directly. There's a red cross here. The traffic from web to app is allowed and app to DB is allowed, right? That's the flow of the internet. So when somebody types cloudexpert.com on his or her web browser, the traffic, the cloudexpert.com is resolved with a public IP. The DNS resolution happens, and then that public IP is found over the internet, and it happens to be hosted here on this web server. So traffic comes on the web server, and web displays the homepage of cloudexpert.com. If you click further on that home page, and if there is any information that needs to come from the database, then the traffic will go to app, and app will send the traffic to DB, and the reverse will be the same reverse order also. So that's how it is working. However, there is a flaw in this design. Can somebody identify the flaw in this design? What's the flaw in this design? The flaw in this design is that it's a single point of failure, which basically means if my web goes down, let's suppose my web server is down, will user be able to access the application or the website?
No.
What if my app is down? Will user be able to access the website? User will still be able to access the website. The home page, the landing page will appear. However, when user will click on some modules, that module will not work. Why? Because app is down. And since app is down, there is no connectivity to the database. And if database is down, then the user will be able to click on the module. However, it will result in an error because the data will not come from the database. So this design is a single point of failure. And how do you make sure that we remove single point of failure in Azure? For that, we create this design. Now, this design does not have single point of failure because what is happening in this design? This design supports high availability. How? If any of the tier fails, let's say for a moment, a web server fails, then both the servers will not fail at the same time. One of the servers will fail. If this server fail, the other server will continue to work. And you can see the traffic is coming to a load balancer. This is the load balancer in Azure. So traffic comes to a load balancer. The load balancer will forward the traffic to one of the web server in the backend pool, which is healthy. Load balancer knows that which server is healthy. Also in this design, I have auto scaling configured. which basically means if both the servers fails, then automatically a third server will get created. Or if there is a huge traffic that is coming on this website, this is Corona time, and this website exactly tells you whether you will get infected or not. Knowyourfuture.com, and the entire world, 7 billion people, is actually browsing this website to know whether they will get infected or not, even though this website will work, because as and when the traffic increases, end user traffic increases, number of session increases, the uh, the auto scaling will continue to provision additional instances here to accommodate that additional load. And at any point in time, you will have at least one instance available to accommodate that load. So this website will always work, even if there are 7 billion people trying to concurrently trying to access the website or browse the website. This is how we design a solution in Azure. Now, definitely it has nothing to do with Entra ID, but this is good to know knowledge that you need to have, right? So you will always design a solution that has no single point of failure, a minimum of 2 instances, and these 2 instances are part of an availability zone, which is another high availability concept of Azure. So the load balancer will forward the traffic to one of the web server, and whichever web server it will forward the traffic, the response comes from that web server again, right? So let's say the load balancer forwards the traffic. So this server is down. Load balancer will forward the traffic to this web server. Then this web server forwards the traffic the to the load balancer, which is front-ending the app server. Then the traffic comes to this web server. Then the traffic goes to the load balancer, which is front-ending the DB, and the traffic goes to this server. Let's say when the reverse comes, when the response comes, meanwhile this server is down, then we will have sticky sessions not configured here. We will avoid configuring sticky sessions, which basically means that any server can respond to any amount of traffic. So this is this is an example of a 3-tier application in Azure, which is internet facing. Then how do you design a 3-tier application? It does not provide security right now because I have not included the security, because the design primarily shows the high availability concept. If you want to include the security, then before the load balancer, before this load balancer, you will deploy a firewall here. And now that firewall will inspect all the traffic that comes into the network. And if that traffic is legitimate, it is forwarded to the load balancer. And from there, it will follow the same path. And to further enhance the traffic, you will put NSGs that will restrict communication from one tier to another. That's on the security part. So you don't need to bother much about network security here, because that's not what you need to know from Entra perspective. But at least you should have this level of knowledge, that what is segmentation, why do we segment, and what is the benefit of a virtual network. Okay, let's move on.
Raghuveer, one question. So Azure application load balancer, I just wanted to check with you, like, is there a difference between an Azure application load balancer and Azure application gateway? Because I have seen in the past
Yeah.
customers are deploying application gateway.
So the difference is, at a very high level, you can understand there is no application load balancer in Azure. Application load balancer is AWS concept, ALB in short. ALB is equivalent to application gateway. So Azure has 4 types of load balancer. Front door. So we have Azure front door. We have Azure load balancer. We have Azure application gateway. Now the difference between load balancer and application gateway is that load balancer works at layer 4 of OSI layer, and application gateway works at layer 7. That's the difference. Layer 7 is application layer. Application gateway has WAF capability, web application firewall, that protects your web applications from layer 7 attacks, which are SQL injection, cross-site scripting, and other layer 7 attacks. That's the difference. Second difference, an application gateway can support SSL offload, which means instead of configuring SSL certificates at the web server, you can directly configure it at application gateway, and the offloading will happen here itself. That's the second difference. The third difference is, an application gateway supports URL-based routing. For example, if you have created multiple servers and your website renders both static content, images, and videos. Instead of putting images and videos on all the servers, you can put them on a separate server. And with the URL based routing, your user can directly connect to a server which is containing the image or the video. So that's how an application gateway is different from a typical load balancer, layer 4 load balancer. However, application gateway is an expensive solution and you should only use when you actually need to, which basically means for a production website, which is mission critical to your business, which renders both audios and videos, then you should use application gateway. Otherwise, load balancer, which works at layer 4, is more than sufficient. Make sense?
Okay. Yeah. Thank you.
You can see the difference here. Azure load. There is a tree also. I'll share load balancing tree that will help you to decide on the load balancer. So this is the URL. I'll put that into the chat window, guys. Okay. Over here, you can see this is the tree. This will help you to decide what kind of load balancer you should be using. So just start from here, and then you can just follow this flow chart, and you can see what type of load balancer you need. For example, you can see start from here. It says your web application, does it require HTTPS? If you say no, then come to this part. So you don't require secure communication. Internet facing application, no. Internal application, use Azure load balancer. If it's internet facing application and it is globally deployed, then use traffic manager plus Azure load balancer. If you need HTTPS, then come down here. If it is internet facing, you need HTTPS, but application is not internet facing, then you should use application gateway. You need application is internet facing plus it requires security and it is globally deployed also. Then you should use the combination of front door plus application gateway. So these are my 4 options: load balancer, application gateway, traffic manager, and front door. These are my 4 types of load balancer in Azure. And this flow chart, decision chart, will help you to decide that which load balancer or which service you will need in what use case. Hope that helps.
Got it. Yes. Thank you, Raghu.
I'm saying if you go to my recorded session, there is a session on load balancing also, wherein I have explained all of this in detail in terms of what are the different types of load balancer, in what scenarios we should be using those load balancers, with a practical example of a 3-tier application by using the same URL here. So if you want to understand this in detail, just go through the recorded session. Otherwise, this information is more than sufficient for a high level understanding. Okay. Great. So
Yes.
this is what a network does. So network filters network traffic. Now, how do I filter network traffic? I have 2 options. I can use security group, which is network security group service, which is also known as a virtual firewall, or I can use a network virtual appliance. Now, what is this network virtual appliance? Network virtual appliance is a terminology that we use in public cloud, NVA. NVA stands for Network Virtual Appliance. Can somebody tell me what is Network Virtual Appliance in Azure? Okay, it is nothing but a next-gen firewall. Next-gen, these days we use the terminology of next-gen firewall. So next-gen firewall is known as Network Virtual Appliance in cloud. If you hear somebody say NVA, it means that the person is referring to a next-gen firewall, which could be Cisco ASA, Palo Alto, VM series firewall, Checkpoint, Fortinet, etc. So you have multiple firewall vendors. Any firewall which is next gen. Next gen basically means it has VPN capabilities, it has IDS, IPS capabilities, it has capabilities to filter the traffic based on port and protocol, URL, keywords. That's a next gen firewall. So any next gen firewall that you deploy in Azure is known as network virtual appliance. And then Azure has another filtering service which is known as network security group In short, it is known as NSG. And using NSG, we can filter network traffic. However, NSG can only filter network traffic based on port and protocol. That's it. It has very limited application. It can only filter network traffic based on port and protocol. However, a next-gen firewall or an NVA can filter the traffic based on URL, based on keyword in the URL, based on port and protocol, plus additional capabilities, which are IDS, IPS, proxy, VPN capability, and some additional capabilities. So these are my two services that I use in Azure for filtering network traffic. Are you with me on this? Yes, no, maybe, guys?
Yes.
Yes,
Great.
yes.
Let's move on. Then it says route network traffic. I'm saying on this presentation, on this slide, I have summarized the entire virtual network service of Microsoft Azure. I'll share the official documentation URL also, and you will see all of this information has been taken from that URL only. Then comes route network traffic. I can also route network traffic using my virtual network. For example, let's understand a scenario wherein my company doesn't have enough budget to deploy multiple next generation firewalls in all the networks that I have. So I have a virtual network in Azure. I have a VPC in AWS. I also use Google Cloud. Now I don't want to deploy next gen firewall everywhere because firewall is needed to filter traffic to provide security. I have my next gen firewall in on premises, in my on premises data center, which is here. So over here, I have a next gen firewall, NGFW. So what I will do, network, virtual network or network in Azure also allows me to forward all the traffic to on premises. So what I will do, I will create a route which is known as user defined route, a UDR, a route table. In the route table, I'll create a route. That route will forward all the traffic from Azure to next gen firewall as the next hop. So all my outbound traffic to internet will be forwarded to this next gen firewall at on premises. Here it will do the filtering, will filter that traffic based on policies or based on definitions that you have configured, and accordingly that traffic will either be allowed to propagate to internet or it will be denied then and there. And in the same manner, I can configure my next gen firewall at on premises to receive all the traffic from internet, even if that traffic is bound to Azure, filter that traffic, and then forward that traffic over VPN or express route to Azure segments. That's the concept of route network traffic. And how this is possible? Through route tables or through configuring BGP routes, which is border gateway protocol. We have different types of routing. People who study networking in depth, they basically do certifications like CCNP, Cisco certified networking professionals. Then they study about various routing protocols, which is IGRP, BGP, OSFP. There are multiple routing protocols. So Azure supports BGP routes, which means using BGP routes or route table, I can route the traffic to any network. That's what routing is all about. So that's about Microsoft Azure Virtual Network. Then comes subnets. Subnets basically means, as I said, that Azure network provides segmentations. So I segment my network into multiple subnets, and I use those subnets to basically host my virtual machines so that I can deploy some roles on those virtual machines, web role, app role, DB role, and I can filter network traffic accordingly. That's the concept of subnets. Now, you can create multiple subnets in Azure. You can create up to 3,000 subnets in one virtual network, and each subnet will have its own IP address range. So it is like LAN and VLAN. This is a simple concept. LAN basically means local area network. For example, you will have an address space for LAN, which is 192.168.1.0/24. This is known as address space. Right? I have one participant in the session who was from networking. Who is that participant? Yesterday, I remember talking to somebody who said that he used to be a networking guy. Do I have that participant available in the session? Okay, no worries. So this is an address space. Address space basically means it's a large IP address. This address space contains multiple IP addresses. In on-premises, we have a LAN address space. Then we create multiple VLANs, similar to Azure, wherein you create segments. And we break this address space into multiple smaller address spaces, which is known as subnetting. So I'll create a smaller address space, which is 192.168.1.0/27. So this address space /24 is known as CIDR block. This basically provides me 256 IP addresses. And this address space that I've just taken from the larger address space provides me 32 IP addresses. So the similar thing I do in Azure. In Azure, when I create a virtual network, I will have an address space for my virtual network, and I will further break that address space, segment that address space into multiple smaller address spaces, which are known as subnets. So that's the concept of subnets in Azure. Now, in on-premises, when you, so for example, this address space provides me 256 IP addresses. And if you want to know what will be my first and last IP, my first IP in this address space is 192.168.1.0. That's my first IP. And my last IP is 192.168.1.255. So this is my first IP, this is my last IP. Now what Microsoft Azure does in on-premises networking, the first IP and last IP is reserved for unicast and broadcasting purposes, for internal purposes. However, in Microsoft Azure, the cloud is different. Cloud networking is a bit different than on-premises networking. This is on-premises. First and last IP is reserved. In cloud, I'm saying this is for on-premise. If you build a network in on-premise, first and last IP is reserved, and the remaining 254 IP addresses can be used to allocate to devices, which is desktop, laptop, servers. In cloud, first 4 and last IP is reserved. So if I want to understand what will be my first IP here, that will be allocated first usable IP, then my first usable IP will be 192.168.1.4. Why? Because first 4 IPs, .0, .1, .2, .3 will be reserved. So this will be my first usable IP in Azure. And similarly, my first usable IP, the last IP, first and last IP will be reserved. So the last usable IP in this segment is 192.168.1.254. That's my last usable IP. So that's the concept of cloud. That's how cloud is different. So networking is, I would say, not 100% different in cloud. It is, I would say, 10-20% different than on-premises. So somebody who has been a network admin or who has been into a networking domain, working with on-premises network, it would not take much time for that person to understand cloud networking. That person only needs to spend a couple of days to a month and become a well-versed with cloud networking also. Okay, saying that cloud is unique in such a manner that it basically provides, that its networking is a bit different. And here it reserves first 4 IP and last IP from each subnet. So which basically means that the more subnets that I create, I will be losing 5 IPs with each subnet. So that is where the best practice of networking in cloud is to reduce the number of subnets. I would not say that reduce them as low as possible. I would say them create subnets, create only required subnet. Do not unnecessarily keep creating subnets. Create subnet based on your application tiering requirement, based on your filtering requirement. That's the best practice of networking in cloud. Okay. So that's what this presentation basically says. that subnet can help improve security and make it easier to manage the network. Each subnet must have a unique address range. It cannot overlap with other subnets. This is another thumb rule of networking, which is common with on-premises and cloud, that your network or your address space must not overlap. When I say overlap, it means two systems cannot have the same IP address. If they have the same IP address, then there will be an issue in communication. The DNS resolution will not happen and they will not be able to communicate over the network. And that is the job of DHCP service, which will allocate IP addresses to devices and ensure that redundant, duplicate, and overlapping IP addresses are not allocated. And Azure reserves the first four and last IP address in each subnet range. So that's what this is. Next, the concept of IP address. We have two types of IP address. I'm saying in general, we have two types of IP address: private IP and public IP. And there are allocation method. Allocation method basically means dynamic and static. Dynamic basically means that whether you have a private IP or public IP, it is dynamic. It is bound to change. It may change. It will change. That's what dynamic is. Static basically means your IP address will remain the same all the time. You provision a virtual machine, allocate a static public or private IP address to it. It will always remain with that virtual machine, even though the virtual machine is turned off, because it's static. However, if you provide dynamic IP address, then the IP address will change every time you reboot your virtual machine, and it will also change after the expiry of lease period, which is typically 24 hours in Azure. That's what dynamic is. So for any mission critical application or server in Azure, I should always go with static IP address. I should always change the allocation method from dynamic to static. Dynamic is the default allocation method. By default, whenever you provision a service in Azure, and if you assign it an IP address, it will always get a dynamic allocation. You need to manually change it to static. So you need to manually navigate to the specific UI and change that IP address to static. Now talk about public and private IP. Can somebody tell me the difference between public and private IP with an example? Guys, what's the difference between public and private IP? It's a very, I'm saying, not that difficult question. Understand, so what we can say here is that private IP is meant for private network and not routable over the internet. Not routable over the internet basically means that is the resource having private IP can't access or is not accessible over the internet. That's the, so the resource which has a private resource basically means machine, device. The resource that has private IP can't access or is not accessible over the internet. Can't access the internet and it cannot be accessed from the internet. That's private IP. Make sense? Then comes
Yes.
public IP.
Yeah.
Public IPs, they are routable over the internet and can access or be accessible from the internet. That's public IP. Now the question is, You will say that my laptop doesn't have a public IP, but it can browse the internet. So the answer is your laptop is connected to a network, be it at home or in your office. That network has a service with the name network address translation, typically configured at router or firewall level. And that service is responsible for replacing your private IP with its public IP when you send a request over the internet. That is why you are able to access the internet. However, your service will not be accessible from the internet. With public IP, you can route it over the internet, you can access the internet, or you can be accessible from the internet. That is why your web servers, when you host a website or an application over the internet, the web services, they are configured with public IP. So you configure a public IP on the web server, or the load balancer which is front-ending the web server, or the firewall which is front-ending the load balancer of the web server, you will configure the public IP. So it is not mandatory to configure the public IP on the same service. You can configure it anywhere in the network. It's just that that IP should be reachable to that service. That's the concept of public and private IP. An allocation method, as I said, for both public and private IP, the allocation method can be static and dynamic. In your office, when you typically travel to your office location, your laptop always gets a dynamic public IP, and that dynamic private IP, and it changes all the time. So probably if you are in office, your laptop has a private IP, and maybe tomorrow it will change, unless and until you are somebody for whom a static IP was requested, because you have some special browsing requirement. You are probably a manager or a director who needs access to certain websites which are typically blocked in your environment. So you need an exception. So to provide an exception, or to VIP users in any company, we use a static private IP, which means that static private IP will be static to your device, and that static private IP will be configured as an exception in the firewall or proxy to allow access to certain resources and URLs which are typically not allowed in your environment. That's the concept of that's what network people do in the as part of their roles and responsibilities. Okay, is everyone with me on this so far? Yes, no, maybe.
Yes.
Great, let's move on. So that's the concept here. You can see we have public IP and private IP concept. Public IP are internet and public facing service. Private IPs we typically configure for internal services, which is on-premises network gateways. Then it shows public IP address. Where can you configure it? You can configure public IP address on a virtual machine network interface card, NIC card. You can configure public IP for load balancer. You can configure it for VPN gateway. You can configure it for application gateway, because they are load balancers basically. Uh, then you can also configure a virtual machine with multiple private IPs. This concept we don't use in Azure anymore, because nowadays you have virtual machines with, in the past, we would host multiple websites on the same server to optimize the cost of that server, right? But today we have servers or resources available with lower configuration also. So to segregate, what we do, we host one website on each server. So since we are hosting separate resources, we don't need multiple links. However, Azure provides you a capability wherein multiple network interface cards or multiple private IPs can be configured on the same machine. That's also possible. Okay, Western host, leave it. Networking, you have understood the concept. I would request you to go through this presentation. Just have a look at it. I'll give you 2 minutes to read the information. This basically shows you those three connectivity options plus features of those options, features and drawbacks or limitations. And you can see which option is better for which kind of scenario. So I actually did this design for a customer in UK when I was in UK. Dineta is a customer in UK who is actually into aviation. So they are They are a subsidiary of Emirates Airline, Emirates from Middle East. So we were actually creating a design for them to host their mission critical applications from on-premises to Azure cloud. And as part of that design, I was to present the networking connectivity solution, and they wanted to understand all the solutions and pros and cons of those solutions. And they only gave me 5 minutes. So they said that our director of networking is only available for 5 minutes. You need to present it in 5 minutes. It's like an elevator pitch. So I put together this presentation and I was able to explain the entire concept with this slide in 5 minutes, that these are my three options which you can go for. And these are the use cases. These are the type of workloads that you can use for. I will say for developers and POC efforts, we can use point to site. For any enterprise or Azure compute services, we can use site to site. And for any mission critical workload, for example, backup DR, high performance computing, we can use express route. And these are some of the common features of these three connections. So go through it. It's a great piece of information, in one slide. All right. So you can see here that express route is the best deal here. However, since this is expensive, it provides 99.9% availability SLA across the entire connection. And definitely this is a bit complex to set up. It involves a third-party connectivity provider who will basically visit your data center, will deploy to high configuration routers in high availability mode, and then configure the tunnel from your network to their or to their network, and from there it will be connected to Microsoft Azure. So those are the connectivity options in Azure. Okay, and the same information you can see here, wherein you can see, I'm saying this is in continuation to that slide, wherein you can see that this is the on-premises data center for the customer, which contains a couple of services. Here you have a gateway, which is nothing, a router or a router or a firewall, and these are the two high configuration routers that will be deployed by network service provider. Those routers will be deployed in your network. They will have a tunnel towards Microsoft Edge routers, and from there, this is your Azure region. This part is Azure. Then the configuration will go to Azure. So at any point in time when the traffic leaves from your network, it will be directly forwarded like this. There is no internet in between. That's the concept of express route. And at, at any point in time, if this tunnel fails, which may not happen, but since it is not 100% SLA, it's 99.99. At any point in time, if this tunnel fails, then you have a failover circuit, which is site-to-site VPN. So this is the failover circuit, which will only be used in case this tunnel is not available, to forward your traffic so that your business doesn't suffer, to forward your traffic to Azure, and from Azure it can then be forwarded to any of the service that you have hosted in Azure. So that's the another design that I basically proposed from networking perspective. Okay, so that's the concept of virtual network. Now let's go ahead and provision the virtual network. That's enough of theory that you need to know from networking perspective or core service networking perspective. Let's do some provisioning. Let's go ahead and provision some network in Azure, and let's perform some hands-on with respect to. So we are going to do some hands-on lab now. So my first hands-on lab is provision a virtual network in Azure with subnets. Okay, provision a virtual network in Azure with subnets, or I would say provision a virtual network in Azure with default configuration. And then you will provision another virtual network in Azure with custom configuration, which is with subnets. Connect two virtual networks to share resources and enable communication. That's what we are going to do. So these are the 3 labs that we need to do. We will need to provision a virtual network in Azure with default configuration. We will need to provision a virtual network in Azure with custom configuration. And then we will connect two virtual networks so that resources can communicate. Now, before we do this part, let's understand this concept also. So by default in Azure, when it comes to Microsoft Azure, two virtual networks don't talk to each other because network create isolation. Yeah, over here. So let's understand this slide. Here I have my training subscription, and in East US region, I have created two virtual networks, virtual network A and virtual network B. And these two virtual networks have one virtual machine in each network. So these two virtual networks, each virtual network has three subnets, web, app, and database subnet. And I have a virtual machine in web subnet here and another virtual machine in web subnet in the other virtual network. Now these two machines wants to talk to one another. And so you want to ping this machine from here and vice versa, or you want to send some data, some file from this machine to this machine. By design, these machines will not be able to talk because they are across virtual network. Only machines inside virtual networks can talk to each other. So if you have multiple machines inside virtual network, for example, if you have this machine here, these three machines in the same virtual network can talk to each other without any trouble. But machines across virtual networks can't talk because these two virtual networks are isolated by design. They don't talk because you have read the feature of virtual network in my slide where it starts with isolation. So it provides isolation. Even though both the virtual networks are created by yourself, they belong to the same subscription, same customer, even though they don't talk to each other. So in order for these two virtual networks to communicate or resources to communicate, we basically create a peering connection. So with the help of peering connection, we allow virtual networks and resources inside virtual networks to communicate with one another. And with this arrangement in place, both network act as if they are one network because resources can communicate without any trouble. However, there is a catch here. The catch is both the virtual network cannot have the same IP address range. Their IP address range has to be different. You can see here, it's 192.168.1.0/24, and it is 192.168 slash dot 2.0/24. So they have two different address space. Because if their address space is same, then you cannot configure the connectivity. So for two virtual networks to communicate with one another, their IP address range must be separate. They must not have identical address spaces. Let's go ahead and do some hands-on lab now. So let's navigate to our Azure subscription. I'm back. And I've also told you that starting from 12 minutes, 25 seconds is when I start to provision virtual network. When first I'm explaining the concept of virtual network, comparing it with how it happens in on-premises and what difference uh, networking or what difference cloud brings in when it comes to networking, and then provisioning the virtual network and configuring the rest of the settings in virtual network till the end of the video. So the duration is around 1 hour, but in that 1 hour, you will get to know everything about virtual network. So you can probably watch this video in your spare time today, whenever you get time. Let's utilize the remaining half an hour that we have in this session today to do the hands-on lab that we just discussed. So let's log into your respective Azure subscription, and we're going to do these 3 labs here. I'll log in also. So the URL to log in is portal.azure.com. Give me a moment. I need to look for credentials. I also redeemed one Azure Pass for myself. Let me just see the credentials for it. Okay, that's my Microsoft Azure subscription. You can also see that my subscription and your subscription is same. It is the same subscription that we have. Mine is also Azure Pass sponsorship. Uh, I'm also an account admin here. The same information that you have in yours. And if I click on the subscription name, and if I just click on this URL, which is Microsoft Azure sponsorship.com, I actually redeemed it probably last week. So if I check my balance, I would have probably incurred some charges here from Azure by now. Okay, so $14 have been used so far, $86 remaining, and I redeemed it on 3rd of September, which is 7 days from now. So on an average, I'm spending $2 every day. And what I'm spending those $2 on, if I want to see, I'll click on usage. To your left, you see usage. Click on usage, and then you will see the subscription. Click on the subscription. It will show you the usage also. For example, uh, there is a virtual machine B2MS for which I'm spending $11. So out that $14, the bifurcation is $11 on the virtual machine, almost $2 on the storage, and then for public IP, I'm paying 68 cents. For disk operations, I'm paying 26 cents. And there was another virtual machine which I only provisioned for not more than 5-10 minutes, for which I was charged 4 cents. And the data transfer on that virtual machine was 2 cents. As I said, data transfer out, anything that goes out, there is a charge. Anything that comes in, there is no charge. So that's how I'm spending the money. Now, the reason I have I have that virtual machine here because I have actually tested some configuration on that virtual machine, and I would like to continue with, oh, that's the reason that virtual machine is charging, because it's running. Now, this should not happen. When you're not using a virtual machine, it should not be in a running state. Probably Farhan was doing some lab and he forgot to shut down the virtual machine. So when the virtual machine is up and running, it will incur cost. So you should always make sure that the virtual machines that you have in cloud, if they are not needed, they should either be deleted or they should be in stopped mode. You should stop them so that you will not be charged for the compute resources. Are you with me on this?
Yes, Raghavi.
Okay, great. Uh, let's just this virtual machine go down. Okay, now how do we build a virtual network in Azure? So since most of you work with Entra ID, Entra has a separate portal also, which is you can type entra.microsoft.com, and this is a new portal that was introduced last year when they changed the name from Azure Active Directory to Entra ID in October last year. When they made the transition, they came up with a separate portal wherein you will only have access to Entra, which is Microsoft Entra Admin Center. And most of the activities, I'm saying all the activities related to Entra can be done here. In this is only Entra. I'm saying all the capabilities that you see, this is related to Microsoft Entra service. However, in Azure portal also, inside Azure portal, you also have access to Entra service. So here you can type in the search Entra and you will see this option Microsoft Entra ID, and it takes you to Entra dashboard here also. So all the capabilities that you see in a separate portal, which is entra.microsoft.com or Entra Admin Center, most of those capabilities are also available here. The reason I'm saying most of those capabilities, because the new capabilities of Entra or some capabilities of Entra are not available here. Microsoft is trying to deprecate this view and enforcing customers to use a separate URL or separate view, which is exclusively reserved for Entra, which is entra.microsoft.com. So we will also be, when we get into Entra space, when we start with Entra topic, all the configurations, all the labs that we need to do, we will do from here. Everything that we need to learn or configure, we will do from Entra Admin Center. And this is just for your good to know information that Entra or Azure Active Directory or Entra continues to be remain available from Azure portal also. Okay. Now, how much time Microsoft will take to remove this feature, remove this UI completely from here? That I don't know. Probably by the end of this year or maybe mid of next year. But let's continue. Let's start to use new portal for Entra, which is Entra Admin Center. Okay, let's come back to Azure. When you want to provision a virtual network in Azure or any service in Azure, you need to search for that service. And the best option is in the search, you can type the first few letters of that service. You can type the service name, and accordingly in the drop down, you will see your search results. So since we want to provision a virtual network, I can click on virtual network and it will take me to virtual network dashboard. This is known as virtual network dashboard or virtual network blade. You can use virtual net service blade or service dashboard here. Now you already have a network here because we created this network to test one Entra capability that I wanted to do for one of my customer who were facing an issue. So I tried to simulate the problem statement in my account, and as part of that, I created this virtual network. In your case, it will be blank. It will say there is no virtual network in your case. So this is one way of reaching to this blade. The other way is you can click on these three dots, three horizontal dots, three horizontal lines. When you click on them, you see an option which says all services. Click on all services, and then under networking, at the bottom under cat, you will see all the services of Azure. Azure has more than 200 services, native services which are available that you can explore and you can use. And they are basically categorized, grouped into categories. So you can click on networking at the bottom here, and it will show you all the networking services or services which are part of networking category. And then you can look for virtual network and click on it. That will also take you to the same plate here. This is the other option of navigating to a service. I always go with this option, which is type the service name in the search and quickly navigate to that blade. But you can use the second option also. At any point in time, you want to reach to the home page. You are probably in the mid of the page anywhere on this UI. You can click on Microsoft Azure here, and it will take you to the home page. This is the home page of Azure or portal landing page or UI or landing UI of the portal. Now, when you use a service in Azure, when you provision a service on the home page under Azure services, you will find that service here. So it populates most of the services that you primarily work with most of the time. And under resources, under recent, you will see the resource. Resource basically that service name. So here you also see that service. So this is some basic navigation that you need to be aware of. Now, practice is the key to success. The more you work with Azure portal, the more comfort level you will get. So just spend some time working with Azure portal, navigating from one service to another, but don't provision a service. Remember, we all have $100 valid for 30 days. So if you lose your $100 before the end of this training, it will be difficult for you need to do this, do the hands-on lab. So follow my instructions. Do not provision service unnecessarily unless and until you actually need to do. And after provisioning, delete them to save cost. So we'll start with virtual network. We are going to provision the first virtual network. And we need to do these three labs, which is the first lab is provision a virtual network with default configuration in Azure. So let's provision a virtual network with default configuration first. So I'll click on create. When you want to provision a virtual network, you will hit create. It will open virtual network provisioning UI, create virtual network, and you will see a couple of tabs here. These are the tabs. You will need to fill information in each of these tabs until you reach to the last tab, which is review plus create. On the last tab, after you are done filling all the information, you will hit create, and it will validate whether the configuration that you have supplied, the inputs that you have provided, are they up to the mark? Do they have any syntax error or any configuration error? If not, then it will validate and it will provision the service for you. This is a common method for provisioning any service in Azure. So we will start with the first tab, which is basic tab. On the basic tab, it will ask you for subscription, which is by default selected, and resource group. Now, what is resource group in Azure? Resource group is like a group, or it's like a folder or a container. So resource group is a resource container. All the service that you provision in Azure, they are provisioned, they are stored into a resource group. There are multiple benefits of resource group. It basically helps you collate all the services uh, that belongs to a specific network together in one folder, one group, so that you can apply rules, you can look for billing, you can delete them together. There are multiple benefits to it. Right now, consider resource group as a folder which will contain all the services that you are provisioning, so that at any point in time, you can navigate to your folder and see, okay, this is what I have provisioned. And you can delete them also, instead of navigating through portal here and there and looking for services. So that's what resource group is here. So what are we going to do here? We are going to create a new resource group. So let's click on create new and type the resource group as SC300. Or you can type the resource group as Azure Training, whatever name you want to give. Please make sure that you create a new resource group. So I would say SC300 underscore TCS, just for the understanding purpose. So I'm creating that resource group, SC300 underscore TCS, and hit OK. So it is going to create a new resource group with this name. Then comes the service name. You're creating a virtual network, provide it a name. So I can provide a name. I can say production hyphen network hyphen A. We will need to create two networks. So I will say production network A. You can put any name. There is no restriction here. And then the region. You need to decide where exactly you are creating your services. So Azure East US is the largest region of Microsoft Azure, which doesn't have any service shortage. So we'll choose East US. And by default, it chooses East US also. So we are done with the first tab, which is basic tab here. All you need to do here is to provide the resource group name, virtual network name, and region. So we have selected all the required configuration. Now we'll go to the next step, which is security. As I told you while we were covering the theoretical aspects of virtual network, that network in a way is a security service. It provides security, it provides isolation to your resources, it provides segregation, it allows you to control traffic from to network, it allows you to browse the internet, it allows you to communicate with on-premises resources. So it's a security service in a way. So networking provides you some additional capabilities. All of these capabilities are paid services, like encryption of your network, Azure Firewall, Azure Bastion Host. All of these are paid services of your network. Give me a moment here. We are not checking any of these boxes. Once again, I'm repeating it. Please do not check any of these boxes. These are expensive service. This will unnecessarily eat your credit. So just leave the screen as it is, but I will quickly explain what these services are. Virtual network encryption will encrypt your network traffic when it travels within the virtual network. This will unnecessarily increase the performance. I'm saying this will unnecessarily increase the latency by affecting the performance. There is no point of encrypting the network, encrypting the traffic when it travels within the network. The perfect example is in your office, when all the people, all the employees are wearing the ID card, then there is nobody who will stop them and say, hey, who you are? Are you a visitor? Then who are you escorted with? Or what are you doing here? So inside an office, you trust all the employees, you know each other. So so there is no point of putting a security control here. But when somebody comes from outside, then you definitely have at the main entrance or entrance of that floor, you will have a biometric device, or wherein you need to punch in your ID card, or you need to put a biometric or a retina scan so that you can be validated, you can be recognized. So that's the concept here. This is a new capability that they have added, wherein you can encrypt the traffic while it travels within the network. But in a production environment, we typically avoid it because encryption and decryption will unnecessarily increase latency and affect the performance unless and until you exclusively need this capability. So we'll leave it. Western is another service which we use in Azure for instead of jump host. You know the concept of jump host, wherein there is a machine that allows you to connect to a network. So that's what Bastion host is. It's a paid service. Azure Firewall is your next gen firewall of Azure. Azure also provides you a firewall. I would not say that this is at par with a next gen firewall service from Palo Alto, Cisco, Checkpoint, Barracuda, Fortinet. Not, it doesn't provide 100% of those capabilities, obviously, because those are advanced firewalls, but it at least satisfies the purpose. 90% of the use cases are resolved with Azure Firewall. So don't check this box. Then comes the next service, which is Azure DDoS protection. This is very expensive service. If you check this box and provision this, you will lost your $100 by EOD today. The cost of this service is almost $100. Give me a minute. So the cost of this service is almost $3,000 a month, which is roughly $100 per day, which means you enable it, provision the network. By tomorrow, your $100 will be gone. So do not provision this service. Do not check any of these boxes. Just click on next tab, which is IP address. Since we are going with the default configuration here, we will also not change anything and go with the default configuration and click next. Last two tabs, tags and review plus create, is common. In all the services that you will provision from today onwards, you will find these two common tabs, which is tag. Tag basically means key value pair. When you travel through airline or through train, you typically put a tag on your luggage. And that tag basically says your name, your contact information, probably your mobile number, your home address, your email address. Why are you doing it? You do that so that if your luggage is misplaced and if somebody finds it, and if that person is honest, they can at least connect with you. They can at least call you, send that luggage to you. That's the purpose of tagging. So it helps you, it helps in recognizing who does that resource belong to. That's the same concept here. When you put a tag here, and if there are 100 employees who use the same portal, by looking at tag, they would know, okay, this resource belongs to Monisha, this resource belongs to Vedant, this resource belongs to Siddharth. And also admin will know, okay, this resource belongs to this person. So that's the concept of tagging. Now, that is not the only use case of tag. Tag also helps you with billing and chargeback. Tag also helps you with security also. You can create security policies based on tags. You can create billing and chargeback based on tags. So for example, I can create a tag with the name cost center, let's say, and I can put the value of cost center here. So I create a tag with the name cost center, and I can put some information of my cost center here. So cost center, and then I can put the information. Now this is my cost center code. So when my finance admin or uh, somebody who manages the billing for cloud, when that person needs to send the bill, they will just go to the tag cost center, and it will populate all the services which are tagged with cost center with this cost center. And they can quickly find out what is the approximate billing of this service or this department or project. So that's the concept of tagging. Right now, you only put two tags, which is name. So you can put your name. Sorry, you can put two tags, which is first tag is purpose. What is the purpose of building this resource? So you can put the tag purpose as Azure training and owner. That who is the owner of this resource. These are the two common tags that you can start to put on all the resources that you will provision, so that you create a good habit and it will help you in the long run. Right now, you all have a separate account I do not have access to yours, you do not have access to mine. So nobody is bothered about these resources, but it's a good habit that you can create from today. Two common tags, which is purpose and owner. And the third tag that you can put, which is environment. Environment basically means whether it's a production resource, non-production resource, or you can put a tag like validity, that what's the validity of this resource. So I'm just giving you some, some use cases for tagging. That's it. So you put the tag here. And after you put the tag, just click on next, which is review plus create. We'll fix it later on. Review plus create, which is the next tab. When you hit review plus create, it will check whether the information that you have supplied is correct, and it will do the validation. So my validation is complete. Only after the validation is successfully complete, you will get the option of creating the service. That create button will be highlighted. So I will hit create button now, and it will provision my default virtual network. This is my default virtual network because I have not provided any custom IP address, or I have not created any segment. Is everyone with me so far? Okay, great. So you can see it is created very quick because you did not provide any much information. So it was quick. If I can directly go to this resource, or I can once again in the search, I can type, I'm saying in the search, I will see virtual network and I will find it here. You can see my production network is created in East US, and this is the subscription name. If I click on my production network, it will take me to the blade. Now this is known as resource blade. So understand the difference between service and resource. Yesterday in the evening, I was taking an interview for one of my clients, and I was hiring a cloud migration architect. That person, I'll say, I will not take the name of that person or provide the employer of that person, but that person happens to be working with a large multinational, and that person has great knowledge of migration. No doubt. He had done a lot of migrations in Azure, in AWS. He has great knowledge of migration. But when I asked him the simple question that what is the difference between service versus resource, he was not able to answer this question. And I really felt bad about it. And that's exactly what happens when you keep moving ahead and you forget the basics. So you should know the difference between service and resource in cloud. The difference is virtual network is the service, and production network A, the one that you've just created, is your resource. So production network A is your resource, and virtual network is the service. So which basically means when you are here, you are on the service blade. This is your service dashboard because it shows you virtual networks, all the virtual network services. However, when you click on a virtual network, and if you move to this window, wherein it shows you specifics of this virtual network, then it's a service. Sorry, it's a resource. So this production hyphen network A is your virtual network resource, and this is your virtual network service. That's the difference between service and resource. Now, you may ask that what is so important about it? Why do I need to know this? You need to know this because Entra ID works with resources, not with services. You will be configuring authentication and authorization for resources in Azure, not for service. That is why you need to know the difference between service and resources. And most of the policies and configurations that you will do with Entra ID, that will be done on resources, not on services. Is everyone with me on this?
Veer, one question.
Yeah.
With respect to machines, so can we say that like virtual machines itself is a service, but VM1, VM2, VM3, etc. is a resource,
Yeah.
or
So
is it?
service, the other differentiation is service belongs to CSP and resource belongs to customer. So virtual machine is a service. VM1, VM2, who does it belong to? Yourself. So it's a resource because it belongs to the customer. And virtual machine belongs to whom? Azure. It's a service provided by Azure. And when you create an instance of that service, so resource is an instance of a service. In other words, you can say resource is an instance of a service. So when you create multiple virtual machines for your business, those virtual machines becomes resource in Azure. And every resource has an ID, a unique ID with which it is recognized. Every resource has a unique ID. So if you are facing an issue with a virtual machine and if you want to raise a service request to Microsoft, what will you tell Microsoft? That I have a virtual machine with the name VMA, which is not working right? No. There could be 1,000 customers who are using the same name VMA. How will Microsoft know which VM? So that is where you will share the resource ID with Microsoft. Every service has a resource ID. For example, this is my resource production network A. If I click on this resource and if I go to its properties, I will see its resource ID. This is my resource ID. This is what I will share with Microsoft. And then Microsoft will know what exact resource I'm talking about. This is the first thing that Microsoft will ask you when you give them a call or raise a support request. There will be a box wherein you need to type the resource ID. And you can see how resource ID is getting recognized. So look at this and you will understand. It says this resource ID is part of a subscription. Here's the subscription ID. Next is subscription ID. This is the subscription ID. So subscription ID belongs to a customer. Now Microsoft is able to recognize that yes, this is for Siddharth. Then comes resource group. Now Siddharth in his subscription has thousands of network. Which network? So then comes resource group. This resource is part of this resource group, which is SC300 TCS. So now Microsoft is able to further drill down out of 1,000 resources that the resource in question is part of SC300 resource group. Then in that resource group, what that resource is a network. Then comes the network. That resource is a network service. Now there are multiple network services. So which specific network service is that? That is virtual network. And what is that virtual network? This is the virtual network A. So when you share this resource ID with Microsoft, they will quickly be able to identify, okay, this is the service or this is the resource in question which is not working right. That's the concept of resource ID. That is why you must understand the difference between service and resource. Make sense?
Yeah. Yes.
Great.
Yeah, got it.
Yeah. That is all for today, guys. I will not be able to, I'm saying we have already reached to the end of the session. It's already 1 o'clock. So we will close the session here. We are done with the first lab, which is provisioning a virtual network with default configuration. Now the next two labs, I want you to do yourself. For that, in the chat window, you already have the recorded session. And starting from 12 minutes, 25 seconds, I am starting with virtual network service description, first theoretical aspects, and then subsequently I'm provisioning the virtual network. So I want you to follow this video and do the lab second and third yourself. This is your home assignment. So second and third is your home assignment. Tomorrow, first documentation, there is also an option. I'll share the documentation also, but I'm 100% sure you will not be able to follow the documentation because it has a lot of gaps. I'll share the documentation also. We'll close the session now. We'll meet tomorrow. And before we do that, the agenda for tomorrow, which is very important. So every day I will tell you what are we going to do next day. Agenda for September 11th, 2024. So tomorrow we will continue. We will resume with virtual network service, and we will also start with, once we are done with virtual network, which will take an hour, by 11 o'clock, we'll be done with virtual network, and then we will be starting with Azure storage service. Now, I still remember yesterday when I took training objectives, most of you, showed an interest in learning virtual network service in detail. So we will basically get into the depth of virtual network service and understand various capabilities that it brings on the table and various integration capabilities with Entra when we reach to Entra topic. So we'll be starting with Azure Storage Account Service. That's the agenda for tomorrow. So the rest of the session tomorrow, we'll continue with Azure Storage Account. So that's the agenda for tomorrow. And these are the assignments for today, wherein you need to provision a virtual network in Azure with subnets and connect to virtual networks, which is create a peering connection. Is everyone with me on this? Okay, great.